Yes, welcome to Grabs Academy. My name is Nagraj, chemistry faculty. I had a 10 years of experience in different institutions like Narayana, Sri Chaitanya. So here I am going to explain about atom. What is the atom? What subatomic particles are presented in that atom? Here, for example, if you observe that this is our atom. In this atom, we are going to discuss. In that atom, what subatomic particles are presented? So everyone knows there are the neutrons are presented, there are the protons are presented, and there are the electrons are presented. So these are the main subatomic particles. Not only these subatomic particles, there are many subatomic particles are presented. Around 35 subatomic particles are presented in the atom. But here we can discuss only about 3 subatomic particles. Those are called what? Electrons, proton and neutrons. In general, protons and neutrons, they are presented in the nucleus. This we are calling what? Center of the atom we are calling what? Nucleus. In this nucleus, protons and neutrons are presented. Electrons are presented out of the nucleus. In the empty space in the atom, electrons are located. So here my concept is quantum numbers, which is located in atomic structure topic. What are the quantum numbers? Think once, if you want to find any person in this world, you need some information regarding that person. What information you required? Which country he is belonging in that world? In that country, which state he is belonging, and which district he is belonging, which village he is belonging. Like this information is required related to person. See, if we want find any person in this world, which country he is belonging, same which state he is belonging, which district he is belonging, which village he is belonging. This information is required along with his name. So similarly, where the electrons are presented in this atom, if you want to find, you require quantum numbers. How many quantum numbers? 4 quantum numbers are required. How many quantum numbers? 4 quantum numbers are required. What are those? What are those 4 quantum numbers? So first one is principal quantum number, and the second one is azimuthal quantum number, and third one is magnetic quantum number, and last one is spin quantum number. So these 4 quantum numbers are required to identify where the electron is located in this atom. If we want to identify, these 4 quantum numbers are required. In general, principal quantum number you can donate it with the letter small n, and azimuthal quantum number you can donate it with small l. In some books they are given instead of n, k also is given. See here, magnetic quantum number, which is denoted by small m. Spin quantum number you can represent it with letter s. These are the quantum numbers. So one by one you can see what will happen, what information they are going to give you. One by one you can learn. So first of all, I will take that principal quantum number. Once again I am repeating, in the atom where electron is located, to identify you need these 4 quantum numbers: principal quantum number and azimuthal quantum number, magnetic quantum number and spin quantum number. So first one I will take, that is principal quantum number. What is this principal quantum number? Who is given? Principal quantum number. So principal quantum number we can denote it with what? Letter n, which is given by Niels Bohr. Niels Bohr is the scientist, is given the information about the principal quantum number. What information you are going to find? So main, it will explain the size of the atom. What is the significance of this? It will explain the size of the atom, it will explain about energy, it will explain about radiation. So you can denote it n is equal to, you can denote 1 comma 2 comma 3 so on, or else you may write k letter, l letter, m letter, m and so on. What is this 1, what is this 2, what is this 3, or what is k, what is l, what is m, what is n. See students, here it is the nucleus, it is a nucleus. So out of the nucleus I am writing the circles, these are calling what? Orbit. The first orbit, this is the second orbit of that atom, this is the third orbit of this atom. So that means this is the principal quantum number orbits. Here you can write this orbit, you can denote it with letter 1. N is equal to 1 means what? N is equal to 1 means what? First orbit. Or else you may denote it, this orbit is k. N is equal to 2 means what? Second orbit, that means what? M. N is equal to 3 means what? Third orbit, that may k, l, m. K, l, m. Like this you can be. That means what? What is giving the information? It is giving the size of the atom. If n is equal to 1, if n is equal to 1, it has a small size. If n is equal to 2, it has some little bit bigger size than first one. So here it is dividing the orbit levels. It is the main orbit, main shell. First n is equal to 1 means what? Main shell. Second shell, second orbit, third orbit. So like this it is giving the information. For example, I want to find how many electrons are presented in the first shell. Or else how many, what I am calling, these circles I am calling what? Orbit. This circuit I am calling what? Orbit. In this orbit, orbit also presented. So I want to find how many orbitals are found. How many orbitals are presented in the first orbit, first main shell. You can know the by using the formula here n square, number of orbits present in main shell or main orbit or main shell, that is equal to formula n square. That means n is equal to 1. That means what? First orbit. In first orbit, how many suborbitals are presented? Only one suborbital. Why? Because n square. That is equal to what? 1 square. That you can be called what? 1. Only one orbit is presented. What orbit is presented in azimuthal quantum number? I will explain. Okay, now if n equal to, if you are taken n is equal to, here n square formula you can use 2 square, that means what? 4 suborbital presented. 4 suborbitals are presented. Here s orbital, here s comma p orbital. In the p, 3 suborbitals are presented. 4 suborbitals are presented. Like this you can write. One more thing you can find, how many electrons are presented in the main shell? That means what? Main orbit. Number of electrons present in main shell or main orbit, which is equal to n square formula. First you can take n is equal to 1. First orbit, I am discussing about the first orbit. In the first orbit, how many electrons are presented? Simply can write 2n square, that is equal to what? 2 into 1 square, that is equal to what? 2 electrons are presented. How many electrons are presented in the first orbit? 2 electrons. How you know? Formula 2n square. How many electrons are presented in the second orbit? Same formula you can use, 2 into 2 square, that is equal to what? 8 electrons are presented. How many electrons? 8 electrons. If n is equal to 2, you can take 3n square, 2n square, 3 into 3 square, 18 electrons are presented. So like that you can be find. What information you are getting from this principal quantum number? Yes, we are finding electrons. In the first orbit, there are the 2 electrons are presented. These 2 electrons are one orbital, in one suborbital is presented. Here, how many electrons are presented? 8 electrons are presented in the second orbit. These 8 electrons are shifted into 2 orbitals, 2 sublevels. One is s sublevel, one is p sublevel. Here s sublevel is presented, here p sublevel is presented, here s sublevel. So here these 8 electrons are distributed into 2 subcells. Like this you are dividing. Later you can find where electron is presented. So this information you are getting. Here n value increases, size of the atom increases. That is nothing but what? Radius of the atom is increases. When you are moving away to the nucleus, energy of that electron also will be increases. Energy increases, size increases when n value is increases. This information we are getting from this principal quantum number. Getting my point, students? Here one more time I am explaining. Principal quantum number which is given by Niels Bohr, which will denoted with letter small n, and here based on the n values you can represent it like 1, 2, 3. This is nothing but what? Number of orbits, number of main shells presented in the atom, and also what sub orbitals are presented in the main shell also we can discuss. So by using this principal quantum number, and you can find how many electrons are presented in the main orbit, how many electrons are present, how many sub levels are presented in the main orbit, that we are discussing. So later you can move for the azimuthal quantum number. Same azimuthal quantum number which is given by Niels Bohr, Sommerfeld. Azimuthal quantum number who is given by Sommerfeld. Who is given azimuthal quantum number? Sommerfeld is the scientist is given. So here second quantum number here I am taking. Second quantum number, it is azimuthal quantum number. This is given by Sommerfeld. This is denoted with the letter small l. So what is the relation between n and l? So here l values you can start with 0, 1, 2, 3, so on up to n minus 1 values you can write. Up to how many you can write? N minus 1. N values are started with 1, 2, 3, but here L values are started with what? 0, 1, 2, 3. So here what is the L value? L value here L is equal to 0. If L is equal to 0, if L is equal to 0, what you are calling? S orbital. It is S subcell. If L is equal to 1, it is the P subcell. If L is equal to 2, that is what? D subcell. If L is equal to 3, what subcell it will be? So yeah, like this so many you can write. L is equal to 4, G orbital, like that. So here L equal to 0, what is the suborbital? Yes, L is equal to 1, P, L is equal to 2, D, L is equal to 3, F subcell. Getting my point? So main importance of this subcell is what? It will explain the shape of the orbital. What it can be explained? Shape of the orbital. What is the shape of the S orbital? S subcell. What is the shape of the S orbital? Spherical in shape. Spherical in shape. That means what? Circle. If P orbital, what is the shape of the P orbital? Dumbbell in shape. What is the shape of the P orbital? Dumbbell. Like this you can write. Dumbbell in the shape. So D orbital. What is the shape of? Double dumbbell. What is the shape of the D orbital? Double dumbbell. Double dumbbell shape. So what is the? You can write like this. And what is the F orbital shape? It is the complex or else fourfold. Complex shape it has. So like this it will explain the shape of the orbital. Oh, S orbital means in what? Spherical in shape. P orbital means what? Dumbbell in shape. What is the use? Here electrons are presented here or electrons are presented, that you can be expected. P orbital means electrons are located like this. S orbital means what? Electrons are here in the spherical, the electrons are presented. So we are dividing that atom where the electron is presented. So shape of the, what is the main thing? It will explain the shape of the orbital. S orbital means what? Spherical in shape. It is very important in NEET point of view. It is very important NEET point of view. They will ask the question, what is the shape of the S orbital, S subcell? what is the shape of the p orbital, p subshell, like that they will ask. They will ask p orbital means dumbbell shape, d orbital means double dumbbell shape, and f orbital means what? Complex in the shape. So here L is equal to 0 means what? S orbital. L is equal to 1 means what? P orbital. L is equal to 2 means what? D orbital. L is equal to 3 means F orbital. This information also you need to be remember. So why you need to be remember this information? Later you can know why it is how much important it has. These are all the things you can understand, right? L is equal to 0 means what? S orbital. L is equal to 1 means P orbital. L is equal to 2 means what? D orbital. In the previous case, here electrons are locating around the nucleus. They are showing some what angle. Here n value, by using n value also you can find angular momentum. mvr is equal to nh by 2 This formula, by using this formula you can identify angular momentum of the electron. Why? Because it is moving with some angle, you can find the angular momentum of the electron. Mass, product of the mass, velocity, radius is called what? Angular momentum. Angular momentum was find. Here it is very important formula. You can find the question based on this also. They will ask the question, what is the angular momentum for the first orbit electron? That means what? N equal to 1, you need to be take 1 by 2 h. 1 by 2 means what? H by 2 you can take. What is the angular momentum for the second orbit electron means what? H by 5. What is the angular momentum for the third orbit electron means what? 3 by 2 into h by 5 means what? 1.5 into h by 5. 1.5 h by 5. In previous exam they are asked question based on this formula also. Similarly here you can find the angular momentum of the electron by use the azimuthal quantum number also. So that you can be find here. This information is given from the azimuthal quantum number. What is the relation between the n and L means L values started with 0 and end with n minus 1 values. So this is the information we are getting from the azimuthal quantum number. Azimuthal quantum number information, azimuthal quantum number mainly given about shapes of the subatoms. Shape of the subatoms. What did you learn up to here? According to board, there you find circles. According to board, what you are finding? Circles. And that means what? According to principal quantum number. By using the azimuthal quantum number, oh, there is in first orbit some subcells also presented like S and S comma P in the second cell, S comma P comma D in the third shell, S comma P comma D comma F suborbitals are presented in the atom. Like that you divided up to here. Next, what we are going to learn about magnetic quantum number. Information it is going to provide. It will give the information about suborbitals. In suborbitals, sublevels we are going to do. See, magnetic quantum number you can take here. Third one is magnetic quantum number, which you can be denoted with what? Small m. Here, what is the relation between L and m? So m values are started with what? Minus L, 0 including and up to plus L. M values are started with what? Minus L, 0 plus L. For example, L is equal to 0. What are the possible m values? You can write, can you write minus 0, 0 plus 0? No need to write minus 0 plus 0. Directly you can take what? 0. Only one value is possible. That is what? S orbit. If L is equal to 1, if you are taken, how many values are possible for m? There are the minus 1, 0 and plus 1. Total 3 values are possible for the m. Total 3 values are possible for the m. For example, here I am writing that is what? L is equal to 1 means what? P orbital. Already you know. Here in this one, Px is there, Py is there and Pz is there. Like this, 3 suborbitals. Orbitals are possible. 3 orbitals are possible. So minus 1, 0 plus 1 means what? We can write minus 1, 0 plus 1. In general, 0 you are using for Pz orbital. In general, what you are using? 0 is useful for the Pz orbital. So if L is equal to, you know that it is a d orbital. Here m values are possible minus 1, minus 2, minus 1, 0, plus 1 and plus 2. Like this 5 orbitals are possible. 5 m values are possible for d orbital. What are those? You can write like this. So here dxy, it is what? Dyz, it is what? Dzx, dx square y square, and dz square. So 0 value in general using for the dz square orbital. 0 value where you are using dz square value. So you can write like this minus 2, minus 1, 0 you can write, and minus 2, minus 1, plus 1, plus 2, 0 you can write like this. So you are dividing orbitals, whatever the values are possible you are writing like this. So main use of this one is it will give the orientation. So electrons are located in the y direction, electrons are located in the z direction, in which direction they are located by using these values. Already you know that d orbital means what? Dumbbell in double dumbbell. For example, it is x axis, it is y axis, where the electrons are located, like that you are dividing, like that you are knowing, right. So it is giving what? Spatial orientation, orientation of orbitals, spatial orientation it is giving. Spatial, where the electrons are locating, in which orientation, in which directions electrons are presented, we are finding. Like India, in South India or North India or East India, like that, here also electron in which area they are presented. That orientation is given by magnetic quantum number. This is the information we are getting for the value. So this is about what? Magnetic quantum number and spin of the electron. Last one, spin of the electron. Spin of the electron. So here what is the spin of the electron? You know that s orbital spin, I am going to explain about spin of the electron, which is denoted with what letter? Well, spin quantum number. See here, which we can be denoted with the letter s, which we can be denoted with what? Letter s here. See what happened here. You know that s orbital means how many suborbital? Only one. So here how many electrons? In any orbital you can fill maximum 2 electrons. In any orbital you can fill maximum 2 electrons. So one electron should be with the up arrow, other electron with use down arrow. If you are filling the electron with both with same direction, this is the wrong representation. And if you are filling the electron with the down arrow, wrong representation. Only this representation in the orbital is correct one. 2 electrons you need to fill with what? Opposite direction. One electron with what? Up arrow, and the second electron you need to represent with what? Down arrow. So this is the spin of the electron. So you can be called what? Positive spin 1 by 2, minus 1 2. So this one, first electron spin is called what? Clockwise direction, that is called what? Plus of. Second electron direction is called what? Anti-clockwise direction. Second electron direction is called what? Anti-clockwise direction. So net spin, plus of, minus of, net spin in this orbit is 0. So like this it will going to explain spin of the electron in the orbital. So first you need to be know the what is orbit, what is orbital. That is the difference between, what is the difference between orbit and orbital? Orbit means what? Main shell. Orbital means what? Subshell. In the p subshell, here 3 p orbitals are presented like px, py, pz. Px, py, pz. That is the difference between orbit and orbital. Orbit means what? Main shell. It is coming from principal quantum number. Orbital means what? So it is given magnetic quantum number. In the subshell we are dividing like a box, that you are calling what? Orbital. So this is the information we are getting. So finally I will write the graph about these 4 quantum numbers, what is given here. Yes, this is your atom, this is your atom. Yes, in this one circles you are writing, these are called what? Main cells. Up to here who is given? Bohr is given. Up to here who is given? This big cells, big levels is given by Bohr. That is what principal quantum number is given like this. I am dividing atom into these parts. Like next one, azimuthal quantum number. Yes, here subshell is presented. That is called what? S subshell. So here subshell is presented. What is this? S and P. So this is S subshell, this is the P subshell. Simply I will write 2s. Why? Because it is related to the second orbit, that is why I am writing CS. Here I will write 1s. Here S subshell is presented, that is 3s. Why? Because it is present in the third orbit, 3s I am writing. Here P also presented. This is called what? 3p. 3p, this is called what 3p, and D also presented, D, it is called what 3. So like this it is given, up to here it is given by azimuthal quantum number. Next one, magnetic quantum number. Here px orbital is there, py orbital is there, and pz orbital is presented. That means 2px, 2py, 2pz. Here 3px, 3py, 3pz, 3px, 3py, 3pz orbitals are presented. 3pz orbitals are presented. Similarly, here 3d, 1, 2, 3, 4, 5. 5. This is called what? Here dxy orbital, 3dxy, here 3dyx, 3dzx, 3dyz, 3dzx, and 3dx square, 3dx square y square, and this is called what? 3dz square orbital. Like this we are dividing the atom. Now we can be find where the electron is presented. Simple questions we can see what will be happen. What are the possible quantum numbers for the last electron of chlorine atom, and sodium atom also can be taken. What is the possible last electron, possible quantum numbers for the last electron in sodium atom? If you take the sodium atom, then chlorine atom also can be taken. Sodium atom atomic number is 11, chlorine atom atomic number is 17. You can write the electronic configuration: 1s2, 2s2, 2p6, and 3s1. This is the last electron of the sodium. So here it is called what? 3 number you are calling what? N, principal quantum number, that is equal 3, and S for L, S equal 0, and M 0. If L is equal 0, M is equal also 0, and yes, spin quantum number you may write -1/2, or you may write what? +1/2. These are the possible quantum numbers for the last electron of sodium atom. Similarly, you can write electron configuration for the sodium atom: 1s2, 2s2, 2p6, and 3s2, 3p5. 3s2, 3p5. This is the last electron of the sodium atom. Last electron is presented in this one. Here also n is equal to what? 3. This you need to be write principal quantum number. L is equal to what? 1, and M is equal to what? You may write what? Where it is presented. Here you can write -1, it is correct, or it's +1 or 0, that you like this you need to be right. So here you can write, and the spin of the electron you may write what? +1/2 or -1/2. Like this you can be right. These are the quantum numbers for the last electron of the azimuthal quantum number, last electron for the chlorine atom. So this information you can find like this. Sometimes they will ask the questions like this: what is the L value for S orbital? That is 0. What is the L value for the P orbital? That is 1. Like that they will ask. So by using these quantum numbers, definitely one question they will ask. Definitely one question they will ask. Very, very important concept in atomic structure. Without this question, no need question paper. Pakka one question or two questions they may ask from this area. In the previous class, I covered atomic structure topic. In that one, quantum numbers I was covered. So where the electron is located, how we are finding, what are the quantum numbers. These are all the things I was discussed. Now what I am going to explain to you, it is very, very, very important concept. That is called what? General organic chemistry. In general organic chemistry, what subtopics are presented? So how much it is useful to you? If anybody want to learn organic chemistry properly, you need to be focused mainly on the general organic chemistry. If you are thoroughly in the general organic chemistry, you can able to solve second year organic questions from alcohol chapter, from carboxylic acid chapter, from carbonyl chapter, and also amines chapter, alkyl halide chapter. From these all the chapters questions also you can able to attempt. That much important is there for general organic chemistry. General organic chemistry. Once again I am repeating, if you are thoroughly in GOC, General Organic Chemistry, you can attempt +2 organic chapter questions also. Not all, few questions. Not all questions I am saying, few questions. It is very, very important chapter. Like for example, if you want to learn mathematics, what are the basic for mathematics? 1, 2, 3, 4. First you need to learn about numbers, tables. Similarly, if you want to learn English, first you need to learn ABCDs. Same thing here also. If you want to learn general organic chemistry, if you want to learn organic chemistry, first you need to learn about the general organic chemistry. In general organic chemistry, reactant will react with substrate or reagent. Substrate, here what you are going to getting some intermediate, then after this intermediate you are getting what product. So intermediate. Reactant will react with what? Reagent substrate or else reagent substrate. So then you are giving what? Intermediate, and product you are going to getting. P means what? Product. So sometimes you may get what? 2 or more products. Which product is more stable? How you can be decide? Based on the intermediate stability. If the intermediate stability is more, the product quantity is more, major product you are going to get. For example, simple reaction I will write. CH3, CH double bond CH2. Here what I am adding? HBr I am adding without in the absence of peroxides here. Propene is HBr. Here 2 types of product I am going to getting. CH3, CH and CH3 here Br. And one more product I am going to getting, that is CH3 and CH2 Br. So first one is what? 2 bromopropane, second one is what? 1 bromopropane. 2 bromopropane, 1 bromopropane. Among these 2 compounds, which one is the major compound? Absolutely I will write it is a major product. It is a major product. Absolutely I will write here it is a minor product. Minor product. Why it is the major? Why it is the minor? Based on the stability of intermediate. Based on the intermediate stability. If the intermediate stability is more, you are going to getting the more product. So why this GOC important means, first you need to learn about stability of intermediate. Which intermediate is more stable? Why? Why other one is not stable? What factors you are going to applying? See here, what factors are affecting this stability? That I am calling, that is called what? Electronic displacement in the covalent bond. Electronic displacement in the covalent bond, that subtopic in GOC I am going to discuss with your peoples. What is the subtopic? Electronic displacement in covalent bond. In covalent bond. Electronic displacement in covalent bond. Very, very, very important topic. Electronic displacement in covalent bond. In this one, what subtopics we are going to cover? First one is what? Inductive effect. First one is what? Inductive effect. And the second one is inductomeric effect. So it is nothing but inductive effect only. Inductomeric effect. Inductomeric effect. And it is what? Next one, mesomeric effect. Sometimes you may call what? Resonance effect. Mesomeric effect. Also you can call what? Resonance effect. Hyperconjugation. Then electromeric effect also presented. So it is also not much important. Electromeric effect. Electromeric effect. Next one, it is hyperconjugation. Hyperconjugation. These subtopics we are going to cover in this electromeric effect. Most important subtopics are inductomeric effect, mesomeric effect and hyperconjugation. These are the main important topics. You can call what resonance effect also. Mesomeric effect also you can call what resonance effect. Here hyperconjugation also you can call no bond effect. Barth-Nathan effect also it has a name. So these are the subtopics in this one. First subtopic I am going to take, that is what inductive merit. What is inductive merit effect? What is inductive effect? What is inductomeric effect? What is inductive effect? First you see that one. For example, here I am taking, here carbon, it is bonded with what metal, and here carbon, here it is bonded with some non-metals, like non-metals are more electronegative elements. So here two cases here I am taking. In this case, here carbon is getting what charge? No doubt here carbon is getting what positive charge partially, and is a more electronegative atom. It is trying to attract the shared pair of electron in carbon and this group bonds. So that is the reason this group is getting what negative charge. So here metal is there. Here this carbon and metal bond. Here shared pair of electrons of carbon and metal bond. Here carbon is going to getting what partially negative charge. Here carbon is getting what? Metal is getting what? Partially positive charge. What is the difference? Why here carbon is getting negative charge? Why here carbon is getting positive charge? There is a difference in electronegativity. Here it is a electropositive element. Because of that reason, carbon is having some little bit more electronegativity than this positive element. That is why carbon is bearing negative, partially negative charge. Here carbon is sharing the electron. Carbon is capturing the electron. So here this bond is called what? Carbon metal bond. Here X is a more electronegative atom than this one. That is the reason it is X, that is some group is taking the electron from the carbon. Here carbon is getting what? Positive charge. Carbon is getting what? Positive charge, and this group is getting what? Negative charge. This group is getting what? Degrees. So here what I am saying, through different conditions you are getting, one case positive charge, other case negative charge. So here what will be happen? Here the electrons are displaces. For example, here I am writing this like this. Here some max, here I am writing this more electronegative atom. You know this one. What happened? This electronegative atom will capture the electron towards itself. Here it is losing electron, because of that reason it is giving electron. It is transfer electron like this. So finally what will happen? This is going to getting more negative charge. Here it is getting what? Partial charge. And next carbon is getting little bit partial charge, not much this one. And next carbon is going to getting what? More partial charge. So here next carbon is going to getting what? Like this partial charge. So what I am saying, whatever the carbon atom directly attached to this electronegative atom, it is affected more. It is carrying more positive charge than other carbon atoms. Here what happened? Electrons are shifting towards more electronegative atoms. Electrons are directed, shifting towards more electronegative atom side. So this effect you can be called what? The inductive effect. What is the effect? Migrating of sigma electrons towards more electronegative atom through sigma bond is called what? Inductive effect. Displacement or migrating, displacement of sigma electrons towards more electronegative atom is called what? Inductive effect. Here electrons are migrating, electrons are moving towards more electronegative atom. That is called what? Inductive effect. So why they are going? Here this inductive effect is what? Permanent effect. Why? Because this halogen, this group will be stay up to the entire this compound. So it is what? Permanent effect, and this effect you can observe up to 3 carbon atoms only. After 3 carbon atoms you can be neglect this effect. This much effect you are not getting. So up to 3 carbon atoms this effect is great. And this inductive effect you can be classified into 2 groups, 2 types, that is plus inductive, plus IE, positive inductive effect, minus IE, negative inductive effect. Because of which groups you are going to getting positive inductive effect? because of which groups we are going to getting minus inductive effect. See here, positive inductive effect is nothing but what? Because of the alkyl groups. Because of the alkyl groups. What alkyl groups? You may take ethyl group, you may take methyl group, you may take ethyl group, like this, C2H5. So many alkyl groups you can be write because of the alkyl groups, because of the alkyl groups. So here plus I, why I am calling here, these are groups, they are donating the electron, then hydrogen atom. They are donating the electron to the positive charged carbon atom. That is why here I am calling what? Plus IE alkyl group. Here I am calling what? Minus I. So here minus NO2 group, Cn, and some halogens, chlorine, any electronegative atom we can be take. These are withdrawing the electron from the carbon atom. These groups, so many groups are there, etc. These groups, what they are doing, they are withdrawing the electron from the carbon atom. That means, in other words, if you want to tell, they are withdrawing electron from the carbon atom. They are not donating more than hydrogen atom. Our reference is hydrogen atom. They can donate the electron, then hydrogen atom. They can not donate the electrons, then hydrogen atom. They are withdrawing the electrons. So based on these two groups, you can explain the inductive effect. What is the use of the inductive effect? So this is inductive effect. These are the two types. Here plus IE inductive effect, minus IE inductive effect. What is the use? Yes, we are going to learn stability of the carbocation by using this effect. What you are going to learning? What are the applications of the inductive effect? What are the applications of the inductive effect? That I will discuss one by one. So here we are going to applications about inductive effect, means in that one, first applications of inductive effect, applications of inductive effect. What applications we are going to learn? The first application in this one is, stability of carbocation. Stability of the carbocation. In this one you cannot cover allyl carbocation, benzyl carbocation. Stability of the carbocation and stability of carbon anions and stability of free radical, stability of the carbon free radical, and acidity of alcohols, very important, acidity of alcohols, not alcohols, acidity of alcohols and acidity of alcohols, and directly I will write carboxylic acids and basicity of amines, So main application of inductive effect is this. It can be explain the stability of the carbocations, it can be explain the stability of the carbon anions, it can be explain the stability of the free radicals. See here, I said already carbocation, in this one don't consider benzyl carbocation and allyl carbocation. That will explain by the mesomeric effect, later we can learn. So here applications of the inductive effect, in that one first application is what? Stability of the carbocation. So always you can remember electron withdrawing groups and electron donating groups. Plus IE groups you can be called electron donating groups. Minus IE groups in general what you are calling electron withdrawing groups. Already I said, I am writing here. So first application is what? Stability of carbocation. Please let me note it. Stability of carbocation. What is the carbocation? That means what? It is carrying the positive charge. Carbon is carrying positive charge, that you can be called what? Carbocation. Carbon is carrying what? Positive charge. Here I will give the first question here I am going to giving, that is, here I had a CH3 plus, here I had a ethyl carbocation. Among these two, which one is more stable? Absolutely I will write second one is more stable than first one. Second one is more stable than first one. Here it is the stability order. It is the stability order of stability. Why it is more stable? Why second one is more stable than first one? So that answer you required. See here methyl, here this carbon having all hydrogen atoms. This hydrogen is not donating electron, not withdrawing the electron from this carbocation. Second compound, if you are observing here what it is attached, CH3 is attached. CH3 is attached. Now what is your carbocation? This is your carbocation. So comparatively here what happened? Here hydrogen is presented, here also hydrogen is presented. This hydrogen get cancelled. Here what happened? Instead of one hydrogen, we had some group, that is what? Methyl group. This methyl group can donate the electron to the carbocation. How it can donate? It can donate like this. So because of this, it is donating group, electron donating group. See what will be happen? Carbocation means what? It is deficiency of electrons. It has the electron deficiency. What it required? Donors are required who are donating the electron to this carbocation. Ultimately positive charge becomes neutral when it is attached to the electron donating groups who are donating because of donating. For example, one poor person is there, he required money, he is attached with what? Some rich friends, and poor person is there, he is attached, another poor person is there, he is attached to the, or he is friendship with what? Poor peoples. Who will get stable? This person, say first person, because he had a rich friends, they will give money to him and he will fulfill all requirements. Similarly, here two carbocations I am taking, here it is attached to the electron donor groups. Here one more carbocation is there, it is attached to the electron withdrawing groups. It is attached to the electron withdrawing groups. Which one is more stable? Means I will say immediately this one. Why? Because it is electron deficient carbocation, carbon. It is electron deficient. It needs the electron. Here donors are there. They are donating the electrons. See, these electron donating groups are donating the electron. So ultimately this positive charge becomes neutral because of donating groups. Here withdrawing, still it has electron deficient, from these only it is withdrawing the electrons. Ultimately what happened? The positive charge increases on the carbon, it is unstable. When it becomes neutral, that is stable. So here because of the electron withdrawing groups, the positive charge ultimately increases. Once positive charge increases on the carbon atom, what happens? It is going to destabilize, unstable. It need to fulfill, it need to neutral this charge. Positive charge is neutral by taking the electrons, but here electron donor groups donating the electrons, this positive charge becomes neutral, reduce, then it is stabilized. This one is destabilized because still it is sufficient, it is deficient with positive charge, electrons, deficiency with what? Electrons. So simple word you can remember, electron donating group attached carbocation is stable, then electron withdrawing group attached carbocation. If there is a competition in between the electron, all carbocations are attached to the electron donating groups only. How we can decide the stability of that carbocation? All carbocations are attached to the electron donor groups. Then how you can decide stability of the carbocation? Means more donor attached carbocation to less donor carbocation. Similarly, there is electron withdrawing groups, that carbocation is attached to all electron withdrawing groups. In such case, how you can decide the stability of the carbocation? Same thing, which one is withdrawing less withdrawing power attached carbocation to more withdrawing power attached carbocation. Like this you can be arranged. This is a carbocation stability. Here methyl group is donated, here hydrogen is not donating, here electron donating, because of that reason it is getting more stable. Few examples I will give. One more thing you can be remember, it is the primary carbocation. How I am saying primary carbocation? This carbocation carbon is directly attached to other carbon, other one carbon, that is why it is primary carbocation. Carbocation carbon directly attached to other carbon, other one carbon, that is why it is primary carbocation. See, I will write more examples. Yes, one more compound. Based on this carbocation stability you can understand it. See here, same here, first carbon CH3 plus I am writing, and the second carbon here CH3 and CH2 plus I am writing, and third carbon CH3 and CH, here CH3 plus, and fourth one here I am writing CH3, C positive charge CH3 and here CH3. Yes, among this one what is the stability order? Definitely I will write 4 is more stable, then third, then second, then 1. It is the stability order. Why it is? Here no donor groups, here one donor group, one donating group, here two donating group to this carbocation, donating group, electron donor group, two donating groups. Here it is what? Electron donating group. Here one more electron donating group. Here one more electron donating group. In the fourth case, there are the 3 donor groups are attached to this carbocation. That is why it is more stable. Donors are more, that is why more stable. And here 2 donor groups are attached to this carbocation. Here only one donor, here no donor groups, no withdrawing groups. That is why this is more stable. In other words, if you want to tell, it is actually tertiary carbon. Why? This carbocation carbon directly attached to 3 other carbon atoms. See, carbon 1, direct second and third, like that. Similarly, here this is a carbocation, this is a carbocation carbon. This carbocation carbon is directly attached to 2 carbon atoms, 1 and it is the 2 carbon atoms. So, it is the secondary carbon. The carbocation carbon directly attached to 2 carbon atoms, that is why it is secondary carbocation. This carbocation carbon directly attached to other one carbon, that is why it is primary carbocation. Undoubtedly can pick up tertiary carbocation is more stable than secondary carbocation, then primary carbocation, then methyl carbocation. This is a stability order for the carbocations. This is the stability order for the carbocation. Thing you can remember, methyl group is less donor, and ethyl group, then propyl group. So blindly what I am writing, if the number of carbon atoms are more, donating power also more. So based on this one you can be remember, if the number of carbon atom is more, the ability of donating is more, that also can be remember. So here the branches are increases, that is the difference. Whenever the questions are coming, we can explain. There you can be understand. No problem, don't worry. Focus on what are the electron withdrawing groups, what are the electron donating groups. If you are focusing on that groups, you can able to answer these carbocation questions. The next question here, it is what? CH3, CH2 plus. And one more group I am writing. Here CH2, here CH2 plus only. Here what I am writing? NO2 right. So among this one, which is more stable, has 200%, I will write here 2 is the less stable than first one. First one is more stable. Why? Here It is electron. NO2 is what? Electron withdrawing group. Here methyl group, here no hydrogen, you can be right. So here electron donating groups it has. Because of electron withdrawing group, already I said, electron withdrawing groups attached carbocation destabilized. Then electron donating carbocations. Here electron donating group is attached here, but here electron withdrawing group. Due to electron withdrawing group, it is going to get at least stable than first one. That is the importance of this one. For example, one more compound I will be right here. 3 I will be right here. If you observe the stability CH2 and CH2 plus the CN I will be right. Cyanide group I am writing. That is also electron withdrawing group. That is also what? Electron withdrawing group. If you arrange the order among these 3, you will get what? First one is what? More stable, then third one will be coming, and second one is the least stable again. Why second one is least stable again? Yes, there is a reason. Cn is a less donor, less withdrawing power. NO2 having more withdrawing power than Cn. Withdrawing ability or power. Withdrawing power is more for the NO2. That is the reason it is getting what? Least stability. That is why we are writing what? Least stability. So these are the explanation we are related to the carbocations. So same thing you can apply on the free radical also. Same concept it is applicable to the free radicals. Yes. Then you can go for the stability of the carbon anions. Stability of the carbon anions. Second one, stability of carbon anion. If carbon is carrying negative charge, that you can be called what? Carbon anion. Yes, if you are observing this thing, in general I will give the 1 point first one. Electron withdrawing group attached carbon anion is the more stable than normal carbon anion, that means what? Methyl carbon anion, then electron releasing group or electron donating group or electron releasing, both are correct only, carbon anion. So in this order you need to be arranged the stability of carbon anion. This is the stability order actually. It is what? Stability of carbon anion. Stability order for the carbon anion. Right. So this order if you write, if you can arrange in this manner, 50% answer you solved. 50% answer will get. See, carbon anion, electron withdrawing group carbon anion you need to be choose. First you can keep in front of the CH3 minus. Then electron releasing groups. In that order you can arrange. In this also, if there is a all electron withdrawing groups, then more electron withdrawing group attached carbon anion to less electron withdrawing group you need to be arranged. Here more donor to less donor to more donor group attached electron releasing groups carbon anion you need to be arranged. In such a way you need to be arranged. This is important, you can keep in your box. So and give the 3 stars, 4 stars, no problem. So here the first question is, here C minus CH2 minus is there, here CH2, here NO2. Second option, second one, first one, second one, H2C, here Cn and here CH2 minus, and third one CH2, here fluorine and CH2 minus, and the fourth one here I am writing directly CH2, here CH2 minus, here I am writing chlorine or bromine, whatever it. What is the stability order means? 100% I will write first one is more stable, then second one, then third one and then fourth one. So it is the stability order. Why? Here electron withdrawing power is more for NO2, then Cn, then fluorine, then chlorine if it is there it will come, then bromine. So like this, electron withdrawing is more for NO2, that is the reason Cn. See here the thing you need to be understand, carbon actually carrying negative charge, that means what? It has the excess of electrons. That negative charge should be down. How it can be down? If it attached to the electron withdrawing groups, then the negative charge ultimately will be decreases on the carbon atom. Electron density on the carbon atom ultimately going to decreases when it is attached to electron withdrawing groups. So here the point you need to be remember is which is withdrawing more, which can be withdrawing more. So that order you need to be remember. NO2 is more withdrawing power. NO2 has more withdrawing power than Cn, then F, then chlorine, then bromine. So if you can identify that withdrawing power order, you can able to write the stability order for the carbon anion. Any carbon anion they are given. First choose which is attached to more electron withdrawing groups. In such a manner you can arrange. In other word, if you can identify primary carbon anion, secondary carbon anion, tertiary carbon anion, first methyl carbon anion is more stable than primary carbon anion, then secondary carbon anion, then third tertiary carbon anion. It is a stability order for the carbon anions. It is completely reversed to the carbocation. What is the carbon anion? How we can be decide the tertiary carbon anion? How we can be decide the secondary carbon anion? Simple reason. If the carbon anion carbon, here carbon anion carbon is directly attached to one carbon, that is called what? Primary carbon. If carbon anion carbon, see it is a carbon anion carbon, if it is directly attached to some other carbon, only one carbon, then you can say this carbon anion is what? Primary carbon anion. If the carbon anion carbon, if it is the carbon anion carbon, it is directly attached to the two carbon atoms, then we can say it is what? Secondary carbon anion. It is what? Secondary carbon anion. Similarly, the carbon anion, if it is attached directly to three carbon atoms, then you can say tertiary carbon anion. You can say what it is? It is what? Tertiary carbon anion. It is the tertiary carbon anion, it is the primary secondary carbon anion, it is the primary carbon anion. Carbon anion carbon directly attached to one carbon, that is primary carbon. If carbon anion carbon directly attached to other carbons, secondary carbon. If the carbon anion carbon, if it is attached to three other carbon atoms directly, that is tertiary carbon anion. So like this you can arrange the stability of carbon anions, carbocations. So once again I am repeating, carbon free radical stability like as a similar to a carbocation. How we are arranging the carbocations, like that we can be arranged. I hope your peoples you can understand the concept of the carbocation and carbon anion stabilities. Now I am going to explain the most important concept is acidity. Acidity of phenols, acidity of alcohols, that we can be arranged here. So here before going to discuss about acidity of phenols, acidity of carboxylic acids. See, acidity of phenols, acidity of alcohols I written, phenols you cannot explain in this one. Acidity of alcohols. See here, this is my alcohol, ROH. This is my water. Here also OH group is presented, right? Yeah. Which one is more acid? Whether water is more acidic in nature or alcohol is more acidic in nature. So you can understand. See, everyone is drinking alcohol. Everyone drinking is water. So which one having the more acidic in nature? That we are going to learn. Alcohol or water. Now only if I ask the question, everyone say like this, alcohol is more acidic, sir. No. Why? I will explain the reason here. Water is more acidic in nature or alcohol is in more acidic in nature. That you can be learned here. See here, what is acidic in nature? See, the compound which can give the H plus ion, the compound which can give H plus ion easily, that has H plus ion easily, that has more acidic in nature. The compound which can give the H plus ion easily, that is more acidic in nature. For example, alcohol I am taking. This is my alcohol. So from here I want to get hydrogen H plus like this, or O minus plus H plus I am going to getting. Clear? Yes. I want get H plus, that is nothing but what, proton from the alcohol. My question is, what bond I need to break? Yes, I know that alcohol, that is what, O and hydrogen bond I need to break. This bond need to break, right? There is the condition. When it can break easily, here if it is attached to electron releasing groups or electron withdrawing groups, in which cases oxygen hydrogen bond can break easily. The cleavage of oxygen and hydrogen bond in alcohol is very easy, in which case, when it is attached to, when that alcohol is attached to electron releasing groups or electron withdrawing groups, in which cases it happen easily, then it can give the H plus ions easily. Once it is broken, no, oxygen hydrogen bond, hydrogen come out easily. So for that, what I am saying, cleavage of oxygen hydrogen bond is easy when it is attached to electron withdrawing groups, electron withdrawing groups, then electron releasing groups, electron releasing groups. See, the alcohol group is attached to electron releasing groups, then cleavage of bond is difficult. If the alcohol group is attached to electron withdrawing group, the cleavage of oxygen hydrogen bond is easy. Why? What is the reason? Yes, there is a reason. See, for example, here it is a electron withdrawing group attached alcohol. So alcohol. So simply here I am writing first OH. Please, you need to understand there is a alcohol group, alkyl group also. Electron withdrawing group OH bond, here I am writing. What will be happen? It is withdrawing the electrons from alkyl group. It is electron withdrawing. Then what happened? Oxygen required. Oxygen going to getting positive charge. Oxygen will take the electron from the oxygen hydrogen bond. There is a necessary of electrons. That is why oxygen hydrogen bond, electrons are shifted towards oxygen side, because oxygen has a more electronegative atom. Then H plus will coming out easily. If there is a electron releasing group, for example, there is a electron releasing group, then oxygen hydrogen bond is difficult. Cleavage of this bond is difficult. Why? Here electrons are donating. Electrons are donating the electron towards the oxygen side. Oxygen is not required to take the electron from the oxygen hydrogen bond. Oxygen is not required take the electron from the oxygen hydrogen bond, because already from this side, from opposite side, electrons are giving to the oxygen. Already oxygen electron rich. It is not required to take the electron from the oxygen hydrogen bond. So in such cases, the bond difficult, breaking of this bond is difficult. So in such case, H plus ion is not coming out that much easy comparatively electron withdrawing group alcohol. So that is why electron withdrawing OH groups are more acidic in nature than electron releasing group alcohols. So here coming to the point, here if you observe the acidity order, shall I write acidity order? So I will write the order. Electron withdrawing group attached alcohols are more acidic in nature. Shortcut point you can remember. So then normal alcohols, after that electron releasing groups or else electron with donating groups attached alcohol. This is the acidity order for the alcohols. Acidity order. This is what I am calling acidity order of the alcohol. See, first alcohol I will write methyl alcohol, CH3OH I am writing. CH3OH I am writing. This is my first compound. Here what I am second compound, what I am writing CH2OH. Here what I am writing NO2. Here what I am writing third one CH2OH. Here Cn I am writing. Which one is more acidic among these three compounds? So 200% you can write second one is more acidic in nature, then third one, then first one. Why? What is the reason? It is what order? Acidity order. What is the order of this compound? Acidity order. See why it is more acidic? Here it is attached to the electron withdrawing groups or electron releasing groups. No doubt it is electron releasing group. Here it is what? NO2. It is electron withdrawing group. Here it is also electron withdrawing group. Already I given the order related to the acidity. Here electron withdrawing group attached alcohols are more acidic than normal alcohols, than electron releasing alcohols. Electron releasing alcohols. See what is the, what did you understand here? So electron withdrawing groups attached alcohols are more acidic in nature than normal alcohols are followed by the electron releasing group alcohols. So here at withdrawing power, if you compare NO2 is what more withdrawing power than Cn. So that is why I written second first, then 3, then followed by 1. This is about acidity order of the alcohols. As coming to the point, already I given the question. What is that question? Initial only I given. Is water is more alcoholic or alcohols are more acidic in nature? Which one is more acidic in nature, whether alcohol or water? So coming to the point here, in case of the alcohols, I am writing like this: CH3OH, OH. Here water, in case of water, HOH. Is hydrogen is not a donor group, hydrogen is not a withdrawing group, but here it is what? Donor group. It is what? Electron donor group. Electron donor group. So that is why it is getting least acidic, but water is more acidic nature. So water is more acidic nature. It is acidity order. Acidity order. So water is more acidic in nature comparatively alcohols. Alcohol. So that you can be keeping. Reason is what? Here alcohol is attached to the electron donating group, but water is not attached to the electron releasing groups or electron withdrawing groups. So water is getting what? More acidic in nature. Yes. So I am going to giving. First one is first question. In this one, first option CH2. Here NO2 I am taking. Here CH2OH. And the second one, here I am taking what? CH2. Here Cl I will take, and here it is what? CH2OH. Then third one, and CH2 Cn and CH2OH I am taking. So this is the order of the acidity. What I am asking, which one is more acidic? Undoubtedly you can write what? First one, then second one, and third one. So this is the acidity order. Third one, then second one. Why it is the second one is least acidic? Here it is a chlorine group. So electron withdrawing group power is more for NO2, then Cn, then Cl. So because of that reason you are getting this order, right? So for example, here I am taking one more question, that is CH3, CH, here Cl I am writing, here CH2, CH2OH I am writing. Can take bromine, no problem, every time why you are taking chlorine. Second compound here what I am taking, CH3, CH, here bromine, and here OH. And third time what I am taking, CH3, C, bromine, and here also bromine, here it is what? OH. Which one is more acidic? Means third one is more acidic because there are the two withdrawing groups. Then second one because it has near to the OH group attached carbon. Here it is what? First one. So why it is order? Distance. Distance also operating here. What happened in this case? First case, here bromine is attached at second carbon. The first here first carbon only bromine is attached. So here near also will be affecting the acidity order. Here bromine is attached to the near OH group attached carbon. So that is the reason here near to the OH group withdrawing power is more. That order you can be right. Why I written third means there are the two withdrawing groups. That is more acidic. Withdrawing groups more, withdrawing acidity also will be more. So this is the acidity order related to the alcohols. Whenever all electron withdrawing groups, there is a competition in all in withdrawing groups, then you can write more electron withdrawing power to the less withdrawing group. Here, if there is a competition in all electron releasing groups, less donor groups to the more donor groups order you need to be arranged. So in such case, we will get the acidity of the alcohols. Then go for the acidity of the carboxylic acids. Then go for the acidity of the carboxylic acids. So very important and beautiful concept. It is inductive effect concept. After this one, you are going to discuss about mesomeric effect. Yes, acidity of carboxylic acids. Acidity of carboxylic acids. Acidity of carboxylic acids. Same concept here, electron withdrawing group, carboxylic acids are more acidic in nature than normal carboxylic acids, then electron releasing group attached carboxylic acids. Same here also you can apply. Electron withdrawing group means what? More electron withdrawing attached carboxylic acids more acidic than less withdrawing group. Similarly, more electron releasing, less electron releasing to more electron releasing groups you need to be arranged. Same order you need to be find here also, like alcohols. See here, carboxylic acid, how they are dissociated. See, it is by carboxylic acid ROH. So this bond you need to be break. This oxygen hydrogen bond you need to be break. Then what you are going to getting? Or C double bond O minus plus H plus. So like this proton you are going to getting. In which cases this oxygen hydrogen bond cleavage easily, no doubt. Electron withdrawing groups attached cases will get that bond breakage. So like this order if you are getting, if you are arranged in such a way, you will get the order of the acidity. You will understand this concept. So example you can see directly, you can understand. So the first example is acetic acid CH3COOH. Second example is what? CH3CH2 COOH. Here I am writing what? CH3. Third one what I am writing? So COOH. Here it is what? CH3. Here it is what? CH3. See how many donor groups are there here? No donor groups here. One donor group. All are donating groups. Electron donating groups. Here how many donating groups? Electron donating groups. Here also electron donating groups, electron releasing groups, both are same only. Don't get confusion. Electron donating groups or electron releasing group, both are same only. Electron donating groups, electron releasing groups, both are same only. See here electron donor group only one is there, no donors. So already said less donor attached carboxylic acid is more acidic in nature. So first you can write acidity order, first is more, then second one and then third one. Why third one is least acidic? Because it has the two donor groups. This carboxylic acid is attached to the two donor groups, then others more donor group attached carboxylic acid is less donor, because when donating groups attached more, cleavage of oxygen hydrogen bond is difficult. Once hydrogen oxygen bond is not in cleavage, you will not get proton. Proton is not coming out, acidic nature ultimately will decreases. This is a relation related to the carboxylic acids. Okay, now this is the order of the acidity related to the carboxylic acids. A few electron withdrawing group attached carboxylic acid I will take and I will explain to you. So then it will be covered. See. Now here one more compound I am taking, that is H3 H2COOH. Here NO2 group is attached. Then here second one CH2, here Cn, COOH is attached, and third one here CH3 COOH, acetic acid. So what is the acidic order means? Absolutely you can write what first one is more acidic than second one, and third one is what least acidic. Why? Because it is electron withdrawing group. Here it is electron withdrawing group, but electron withdrawing power is more for the NO2. Electron withdrawing power is more for the NO2, that is why it is more acidic in nature. More acidic in nature. This is the order, it is related to the carboxylic acids. One more compound I will take, then you can understand. So, acidity order of the carboxylic acids, and we can finish this session. In the next session, you can discuss about mesomeric effect and basicity of amines also can be discussed, right. See here, the next question here, CH3, CH2, COOH. It is the first compound, and here I am attaching what, bromine or NO2 I will be attached, then CH3, CH, COOH. Here what I am doing, here this time NO2 group attached here. In the third case, CH3, C, here NO2, here also NO2. So, here which one is more acidic means you can write the third one is more acidic than first one, then second one. Here what is the relation between first and third? So, among these all there is a 2 electron withdrawing groups, that is why it is more acidic. Here this in between these two are having the same withdrawing group and their positions are different. Here NO2 is near to the COOH group, that is why it is more acidic in nature than second one. There is distance is the factor, but here number of withdrawing groups are the factor. So, that is why third one is more acidic than first one, then followed by third one. This is acidity order related to the carboxylic acids, right. So, this is concept is involved in that. Actually, one more topic is there, that is amines topic. That amine topic I will discuss in the next session. In the next part it will be coming, and also we can discuss about mesomeric effect in the next class. So, please all of you concentrate and focus on the stability of the carbocation and this acidity of the phenols and acidity of the alcohols and carboxylic acids. If you want answer to these questions, first you need to be learn about what are the electron withdrawing group according to inductive effect, what are the electron donating groups, nothing but what electron releasing groups according to inductive. In that one you need to be focused. If you learn that plus IE groups, minus IE groups, you can able to answer all these questions. So, very important concept. Please all of you concentrate on this one. In the next class I will discuss about what mesomeric effect, that is also beautiful topic, later we can discuss. Thank you for